Alright, this last section in this chapter, we're going to look at how we solve equations that have fractions. And our basic idea is simply to, if I have an equation with fractions, is I want to turn it into an equation without fractions. So we start this by figuring out what is the least common denominator of all the fractions, and then we multiply both sides of the equation by the LCD. That will, if done correctly, always result in an equation with no fractions. So let's start out. In example 326, my denominators are 12, 8, and 6. They're all numerical, so I'm just thinking about trying to figure out what's the smallest number that 12, 8, and 6 all go into, and that would be 24. So I'm going to multiply both sides by 24. Now I'm going to rewrite this equation by distributing the 24. Now some people will distribute and simplify as they go, but I'm going to kind of write out the whole step just to kind of show you in effect what we're doing when we multiply both sides by the LCD. So on the left side, when I distribute the 24, I have times 24, and I'm writing it as 24 over 1 because I want it to look like a fraction. And then I distribute, so times 24 over 1. And on the right side, I have times 24 over 1. And we could see that when we multiply both sides by the LCD, we're just zapping every term in the equation with a factor of 24. Now I'm not going to multiply it out. I'm not going to, distribute 24 times x plus 2 on the right side, for example, because the reason that we're multiplying by 24 is because it's going to cancel with all of, each denominator that appears. So 12 goes into 24 twice, and this first term becomes just 2x. The denominator is 1 now, right, because it cancels, so it's not I don't have to write it as a fraction. 8 goes into 24 3 times, and so that second term becomes just 3, and 6 goes into 24 4 times, and so the right side becomes x plus 2 times 4. Now this is an equation with no fractions that we already know how to solve. In fact, it's linear. We've been solving these equations for quite some time now, so we're going to start by distributing that 4. So 2x minus 3 is equal to 4x plus 8. I'm going to move over here for some more room. Let's see, let's get all of our x's on one side. Let's subtract 4x from both sides. And then we can add 3 to both sides. On the left side, we're left with 2x. On the right side, we have 11. And now it's all over but the shouting. We'll divide both sides by 2. And we find that x, is equal to 11 halves. Alright, let's do another one. 5 over n plus 2 equals 3 over 2n. In this case, our denominators are not all constants, so the LCD, I'm just going to grab all of the factors that I see. The denominators are already factored, so I don't have to do any factoring. But to grab all the factors I see, I need a factor of 2 and an n and a factor of n plus 2. So I'm going to multiply both sides by 2n times n plus 2. I'm going to do some canceling here, n plus 2 with the n plus 2 on the left side, which leaves me with 2n times 5, or 10n. And on the other side, I've got to cancel those 2 n's, which is really I'm canceling the 2 and I'm canceling the n. And that leaves me with 3 times n plus 2. Again, now we have an equation with no fractions that happens to be linear. We know how to solve this. We'll distribute that 3. Now, let's see. All of our constant terms are on the right, so I'll just subtract 3n from both sides. And we have on the left side 7n, which is equal to on the right side 6. And now we're just about done. We'll divide both sides by 7. And we find that n is equal to 6/7. Now, as we solve these, one thing we have to keep in mind is that it's possible to get what we call extraneous roots, which means, you know, we could do everything right algebraically and get a result that doesn't actually solve the equation. And so what we want to do is just be on the lookout for values of the variable that make us divide by 0 in the original equation. So in the original equation, the only values that would make us divide by 0 are -2 and 0. So we got n is equal to 6/7, and that's fine. In the first example, our denominators were all constant, so there was nothing that was going to make us divide by 0 there. Let's continue. In this next example, we have to start actually by doing a little factoring. When you're solving an equation with fractions, you want to start out by factoring all of your denominators. Now, there's not a whole lot of factoring to do. Really, it's just this first one. We can take out a 2 and be left with 2x minus 3 plus 1 over 4 equals 5 over 2x minus 3. So now the LCD, if I want to grab all the factors that I see, I need a 2 and a 2x minus 3, and then I have this factor of 4. So in fact, what I really need is a factor of 4 and a 2x minus 3, because that will include the factor of 2 that we need. So there's our LCD. And I'm going to multiply all terms by the LCD. Now I can do some canceling, right? All of our denominators, if I've chosen my LCD correctly and I go through this and don't make any mistakes, my result after this step will be an equation that has no fractions. So here I can cancel the 2x minus 3. 2 goes into 4 twice, so this first term is 6. In the middle term, the 4's cancel, and I'm left with 2x minus 3. And then on the other side of the equation, the 2x minus 3's cancel, and we're left with 5 times 4, which is 20. So there's an equation, a linear equation with no with no fractions, right? The denominators are all 1. I'm going to simplify the left side. We have some like terms here. 6 minus 3 is 3, so this becomes 2x plus 3 equals 20. I'll subtract 3 from each side. So we get 2x equals 17, and now it's all over but the shouting. We'll divide through by 2, and we find that x is 17 halves. And you could do a quick check, but 17 halves will not make either of these denominators equal to 0. All right, our last example. We're going to begin again by factoring denominators. There's no factoring to do on the left side, so I'm going to rewrite this just by giving myself a little bit of space after each term. On the right side, we could factor that denominator by taking out an x. And so that's x times x plus 1. Now, looking at the fractions that we have here, the LCD is x times x plus 1 times x plus 2. All right, so I need to have all 3 of those factors present. I'm going to multiply through. Every term's going to get zapped with the LCD. And now we're going to sort of do the canceling we can do and see what we're left with. So in this first fraction, the x plus 2's cancel. We are left with 2x times x plus 1. In the middle, the x cancels, so we're subtracting the product x plus 1, x plus 2. On the right side of the equation, the x cancels, the x plus 1 cancels, and we're left with negative 2 times x plus 2. Okay, now we need to expand this out and combine like terms. Here we've got 2x squared plus 2x. In the middle, I'm going to do this in 2 steps just to try to avoid sign errors. So I'm going to subtract off what I get when I FOIL this out. X squared plus 2x plus x is plus 3x plus 2 equals negative 2x minus 4. Okay, so now I'm going to distribute that negative. Combining like terms, x squared, 2x squared minus x squared gives us an x squared, and plus 2x minus 3x gives us negative x, and then we have minus 2 equal to negative 2x minus 4. So this equation is not linear, and we're actually going to get a sneak peek into some of the techniques we're going to learn in the next chapter. But to start out, here's what we're going to do. I'm going to collect all my terms on one side. And we get x squared plus x plus 2 equals 0. So I have this equation. This is in fact what we call a quadratic equation. We're going to look at them in depth in the next chapter. But we kind of have the skills really to solve this already. So I'm going to begin. Since it's set equal to 0, we can factor the left side. We're good at factoring. We'll have an x and an x, a 2 and a 1, and let's see, plus 2 minus 1. So the only thing, here's the jump that we're making that we haven't quite learned yet, but we're getting a sneak peek at it before we start the next chapter. I'm multiplying 2 things and getting 0. And the only way you can multiply 2 things and get 0 is if one of them were 0 in the first place. So the only way this equation could possibly be true is if x plus 2 is 0 or x minus 1 is 0. And that will give us 2 solutions. We get x equals negative 2 and x equals 1. So it looks like there's 2 solutions to this equation, and these 2 are absolutely solutions to this equation, right, and this equation. But if we check this up here, we'll note that the LCD is x times x plus 1 times x minus 2. And that comes from seeing, what factors are present in my denominators to begin with. So in this equation, the one that we're given, x is not allowed to equal negative 2, because if x is equal to negative 2, it makes us divide by 0 here. Also, x is not allowed to be 0, because it would make us divide by 0 there, and x is not allowed to be negative 1, because it will make us divide by 0 in that fraction. So looking over here, that causes me to conclude that this x equals negative 2 is not a solution, because this leads to division by 0. And so in fact, the equation they gave us has just one solution at x equals 1. X equals negative 2 is what we call an extraneous root. We've done all the algebra correctly, and x equals -2 is in fact a solution to this equation that doesn't have any fractions in it. It's just not a solution to the equation they gave us.